Okay, guys, we are back to actually, it's no longer Happy Star Wars Day. Well, it actually is still Happy Star Wars Day at my house. But by the time you see this, it will not be Happy Star Wars Day. It should be Happy Cinco de Mayo. Funny story, which maybe you will not think as funny as I do, but when I first moved to California and I was 22 years old and I was here from Michigan, where I took German in high school and then I moved and they didn't have German, so they said, okay, you can take French or Spanish. And I said, when would I ever use Spanish? I'll take French because I thought I could go to Canada and speak French. And here I am living in Southern California. And I arrived and they kept talking about Cinco de Mayo, Cinco de Mayo. And I said, well, when is Cinco de Mayo? Long pause. Yes, I have learned since then. I probably shouldn't even tell you that because now you all think I am totally dumb. But anyway, back to our solving problems with common bases. Okay, again, once you have a common base, if the bases are the same, then the exponents will be equal. So on this first example we looked at yesterday, my base is 3, my base is 3. That means this exponent has to be equal to that exponent. So x minus 2 equals 4, which means x is 6. Woohoo! Okay, on this second one, remember we said this was 5 to the negative 1. Now, the shortcut, if you're doing a power to a power, again, is to multiply them. So this is really 5 to the negative x, or negative 1x, equals 5 cubed. So again, bases are the same, which means the exponents, negative x and 3, must be equal. So if negative x equals 3, then positive x will be negative 3. Okay, my 7s, same thing here. This 49 is really 7 squared. So I really have 7 to the 4 minus x equals 7 to the, multiply those things together, 2x minus 2. But again, now my bases are the same. So the exponents have to be equal. And we're going to solve that equation. So I have x's on both sides, numbers on both sides, get my x's to the same side. Which x do I want to move? I mean, you can move either, it doesn't matter. But you know me, and which one am I going to want to move? Yes, I am going to want to move the negative x so that it will turn positive. So I'm going to add an x, and then I'm going to add a 2. Not to be confused with attitude. So 6 equals 3x, and x will be 2. Okay, so some practice problems here. Hopefully you guys did what I asked and you found my common basis. So this is going to be 2 to the x minus 4 equals 2 to the 5th. So x minus 4 is 5, which means x is 9. All right, add 4 to both sides. Okay, the easier way to do this one, I think, is to use 4 as my base, although you could use 2 as your base. It's just like an extra step in there. So 64 is 4 to the 3rd to the x minus 1 power, and that's 4 to the 1st. So again, my bases are the same. I'm going to multiply that piece. So 3x minus 3 will be equal to the 1. So add 3. All right, and then divide by 3. So x will be 4/3. Okay, this one is 6 to the x. 216, the common base is also 6, and that's to the negative 3 power. And so that's just a straight across x equals -3. You don't even need to solve with that one. Okay, 4, I said the common base is not 4. It's going to be a 2. The reason it's not going to be a 4 is if you try and do 4 to powers, 4 to the first is 4, 4 to the second is 16, you've missed the 8. Okay, so 4 is going to be 2 squared to the 1 minus x power, and 8 is 2 cubed. Okay, so the power on this side is really 2 minus 2x. The power on this side is 3. Take 2 away from each side. And x is 1 over -2, or x is -1/2. Same thing. Okay, number 5, your common base is 10. So again, that's a 10 squared to the 2x and a 10 to the 3x plus 2. So I'm going to have this power is 4x. This power is 3x plus 2. I'm going to solve for that. Take 3x from both sides. And x equals 2. Okay, I have a feeling this might be getting too long, so I'm going to stop here and do a part 2 and finish the other examples.